All right, so 7:1, ratio and proportion. A ratio is a quotient of two numbers, A over B, or sometimes you write it A colon B. But a ratio, if I were to use just a single word in place of ratio, I would say it's a fraction. Usually in math, we write ratios as fractions. Sometimes we'll write them, like we're talking about scale models and things like that, you'll see it written as with a colon in between. You'll be asked to simplify some ratios. What makes this a little more difficult is that we've got to get it into like units before we can simplify it. So we've got to think a little bit about this. Like, for example, 12 centimeters over 4 meters, we need to get them in the same units. So we could change the 12 centimeters to meters. We could do that. I don't really want to do it that way because that would be a decimal in terms of meters. Or we can change the 4 meters into centimeters. Do you remember how many centimeters 4 meters would represent? We have 12 centimeters over 400 centimeters, and then we could simplify it. So 12 over 400, when we have even numbers, sometimes what I'll do is just start cutting them in half. I don't know if you do that too, but 12, half of 12 is 6, half of 400 is 200, half of 6 is 3, half of 200 is 100, so I end up with 3 over 100. I cut it in half a couple of times. You might also, what happens to centimeters? If you're talking about common units or things like that. If I have centimeters over centimeters, the ratio is just 3 over 100 and centimeters really just cancel out. But that's the simplified ratio. 4 goes into each of those. You may have seen that right off the bat. 4 is the biggest common factor. What about B here? 6 feet. How many inches would that be? 72 inches. Has anybody in here 6 feet tall? Somebody's exactly, are you exactly? Okay. So 72 inches. 72 inches. And if you're a basketball player, you take it. Over 18 inches. And then you simplify it. Is 18 going to 72 evenly? How many times? So this would just be 4. It simplifies to 4. If you write it as a ratio, it's 4 over 1. You may have talked about that in Algebra 1. We usually like to write the slope as a ratio, even if it's a whole number. Because 4 over 1 would tell us to go up 4, right 1. Not just up 4 and stop there, directly above wherever the previous point was. So. And then 100 meters over 2 kilometers. 2 kilometers, how many meters is that? If I change the bigger one of the two to meters. 2,000 meters. And then we got 100 meters up here. And you can just lop off the zeros, right? Take those zeros off, and it's 1 over 20 is my ratio. So there's the simplified fraction. So you'll be asked to simplify some ratios. Be a little bit of that. And then you'll also be asked to solve some proportions. We're going to use a proportion in this next one. We're going to jump right into proportions. A proportion is simply one ratio equal to another. So proportion brings in an equation. Okay, proportion is an equation because you have one ratio equal to another. And the method we use for solving a proportion is cross multiplication. So we're going to set up some proportions here. Here's one. It says the perimeter of a rectangle is 216 centimeters. The ratio of the length to the width is 3 to 2. Find the length and the width. So we have the perimeter. Oh, this is a little different. We're going to actually set up an equation to solve this. So this won't be a proportion yet. But here's what it's saying. Let me draw a picture. The length to width. So the length we'll say is 3 times something. And the width, we'll put 3x here for the length. And 2x. Here's the reason why I'm placing 3x and 2x and not just 3 and 2. I don't actually know what the length and width are, right? If you think about it a little bit, it can't be 3 and 2. Why not? What does the perimeter have to be? Way bigger than what the 3's and 2's would add up to, right? 2 3's and 2 2's would add up to 10. That's a little bit shy of 216. So it's really 3 times something and 2 times something. So what they've done here is exactly what I did up here, right? They reduced it down. its simplest form. So it's really 3 over 2. So we're going to find out what that value x is, and then multiply it by 3 and 2 respectively to figure out the length and the width. So we're going to use a little bit of algebra here to look like this. How many of those 3x's do I have in this rectangle? 2 of them. So I have 2 times 3x. How many of the 2x's do I have? 2 of them. And 2 times 2x. And that somehow that's going to equal a perimeter of 216, right? Or you could think of it as just adding all 4 of these up if you'd like to. So a little bit of algebra. You have 6x plus 4x. And they created a problem here that is not a whole number. So if you were guessing and checking your way to the answer, it might take a while. Right? So what does x equal here? 5 by 10. Just a matter of moving the decimal one place to the left. I get x equals 21.6. Do you see what I mean? We would have had a tough time guessing and checking our way to find a combination that worked, right? So 21.6, let's just double check that, make sure that works. 3 times 21.6 gives me a length of 64.8. Is that right? 64.8. And then 2 times 21.6 gives me 42 and 43.2. So if you put these two together, that's 108. And if you double 108, you get 216. Yeah. So that was a good one to look at because we actually have to use a little bit of algebra to get it. I guess we didn't have to. But you would have gotten down to a point where you were maybe between 21 and 22 as your guesses, and you would have had to then start using decimals. So good one to look at. So here it is. The length is 64.8. What are units? Centimeters. And the width is 43.2 centimeters. So using a little bit of algebra to solve that. Does that make sense on the setup? You understand how I got the 3x and 2x? I guess that's something new. Does that make sense? It's 3 times something and 2 times something to get that ratio because of the fact that it's been reduced. Same deal here in example 3. It says the lengths of the sides of a triangle are in the extended ratio. Extended just means they don't just have 1 colon, they have 2. So it's 3 to 4 to 5. It's an extended ratio. You could do that as for 4-sided, 5-sided shape. It doesn't matter. The perimeter of the triangle is 98 inches. What is the length of the longest side? So if we think about it here, we have a scalene triangle. Try to draw a scalene triangle here. This would be the 3x side. This would be the 4x side, maybe. 4x, and this would be the 5x. I'm not necessarily trying to make it look like a right triangle. It's scalene. It could be a right triangle. We'll talk more about that later. 3, 4, 5. But 3x, 4x, and 5x. Now think about perimeter of the triangle. Oh, I'm sorry. Oh, okay. That's funny. Yeah, I'm on chapter 7 for both algebra and geometry. So make sure everybody has the geometry hat. So we're going to add all 3 of these up. 3x plus 4x plus 5x, and that's got to equal 98. Do you see why I'm not doubling them or anything like that? Perimeter of a triangle is just adding up the 3 different sides. Okay? Up here it was double the length plus double the width. So 3x plus 4x plus 5x equals 98. So I've got 12x equals 98. Divide 98 by 12. Going evenly. Quite. So I take out my trusty calculator, do 98 divided by 12. What do you get? 8. Was it? You know on your see on there, I should show you on my calculator. You can actually get a fraction for that, but it's It ends up being 8 and 1/6. That's what that 0.166. It's just 1/6. So it's 8 and a 6. You could probably round that to 8.2. That would probably be okay. But it says, what is the length of the longest side? If we want to be exact, we need to leave it as 8 and 1/6. Okay. The way I got 8 and 1/6 is that 12 goes into 98 8 times with 2 left over, 2 12s. So 8 and 2 12s, which equals 8 1/6. So we're going to take 8 and 1/6, or let's think of it this way. 48, that's 49/6. And we're going to multiply 49/6 times 5 to get my longest side. So once again, we're doing that Common Core sort of thing where you're using geometric properties. That's the perimeter of the triangle to get an algebra equation, and then you're solving the algebra equation to then answer the geometry question. So 5 times 49 would be 245 over 6. As a decimal, 6 would go into there 4 times. 40. Let's see, it's 40 and 5/6. So longest side is 40 and 5/6 inches. There you go. Another one that forces you to do a little bit of algebra. So I'm just multiplying 5 times 49 to get 245 divided by 6. 6 goes into 245 40 times with 5 left over. So I get the 5/6. Fun fraction. It's kind of the theme here because we're looking at ratios and proportions. There'll be lots of fractions that show. 40 and 5/6 inches is the longest side. And the reason I asked this is because that's what they're doing in the problem set too. They're going to ask things like, what's the shortest side, what's the longest side? They may ask you for all 3 sides. Just read it. Any questions on those? Those two are kind of similar. There's some problems like that in homework. Okay. Proportion. Here's what a proportion is. It's the equation of 2 ratios. And there are several properties of proportions listed below. At least one of which you already know. The first one. So equation of 2 ratios, A over B equals C over D. You might want to write it like this. And the first of the properties is, this is the one you know from algebra. If A over B equals C over D, then A times D equals B times C. In other words, you cross multiply to solve a proportion. There's some other properties that that are kind of nice to use. You haven't seen these before, but they're true. One of them is that if A over B equals C over D, then it's also true that you could reciprocate them. You could say B over A equals C over D. Think about this. If I look at the cross product, what are the cross products when I reciprocate them? Same things up here, right? So if it works, you can flip them around. So we talk about that sometimes in algebra. What's a way to set up a proportion to solve this equation in algebra? And you can say, well, it doesn't matter if I flip them around, right? As long as I flip both of the ratios, okay. It's also true that you can swap diagonally at any point. That's what this third property says. It says if you have A over B equals C over D, it's true that A over C equals B over D. In other words, you can swap C and B. You can also swap A and B. That's really helpful. I'll show you when we get to something like that. I'll show you it's really helpful. To shorten up, it takes one less step to do the algebra to solve it. If you have a variable on the bottom of the fraction in the proportion, you can move it to the top by swapping diagonally. So that always works. I don't know if you knew that already or not, but that's one of the properties of proportions. It's really helpful. And then this one right here, if A over B equals C over D, then A plus B over B equals C plus D over D. The reason that works is that because here's what I'm actually doing. I'll write it down for you here. I have A over B, and I am adding B over B to it. And I'm saying C over D is equal to D over, or plus D over D, sorry, plus D over D. So what I'm actually doing here, if I kind of break it into two fractions, is all I'm adding to A over B is 1, right? B over B is equal to 1. You with me? And then on the right-hand side, what I'm actually adding to C over D, 1, right? And so it's true, and this property you won't use, I don't know you'll use this much, but if I add whatever's on the bottom to the top, and whatever's on the bottom to the top of the other one, they're still equivalent, but this is why. I'm really just adding one side, and I'm totally allowed to do that in algebra. So let's go ahead and solve some proportions. It's a little bit, there's more algebra. This is just algebra. We're going to cross multiply to solve, so it looks like this. This would be 4 times 7 equals 5 times x. So 28 equals 5x. Divide by 5. So x equals 5 3/5. Or you could write that as 5.6. The reason I avoided writing that previous one is like whatever it was, 8.166 repeating. So, it's because I wanted an exact value. But this one, you can change it to a decimal, and 5.6 would be exact. Be careful about just cross-multiplying and then dividing and doing that all on your calculator. That will not work for the next two problems. Here's why. I have parentheses around the y plus 2. Go ahead and put parentheses around the y plus 2. When I cross-multiply here, I have 3 times y equals 2, and then parentheses y plus 2. And so what that does is it forces me to distribute the 2. I have 3y equals 2y plus 4. It's distributing the 2. Don't just multiply the 2 by the y or the 2 by the 2. I'm going to distribute it to both terms. And then I can subtract 2y from each side here. Show you what it looks like. And I get y equals 4. So what this says, if I've done this correctly, is I can place a 4 in for y here and here. And the left side equals the right side. Let's just double check that. This is 3 over 6, which is 1/2. And this is 2 over 4, which is also 1/2. Right? So I found the value y through algebra that makes the left side equal to the right side. So if you've done your algebra correctly with the cross multiplying and solving, you should be able to plug it back into the original proportion, and it will make the left side equal to the right side. Okay. What about here? I'll do some different color. We've got 2 times 3 minus x equals 6x. What some students will do is skip to the next step that I'm about to write. A lot of students will go ahead and do the distribution in their head, and I'm okay with that. So you would have 6 minus 2x equals 6x. It's totally fine to do that. Just don't forget to distribute that 2 to both terms. Add the 2x over to each side. Add the 2x to each side, so we have 6 equals 8x. And then divide by 8. And so 3/4 equals x. So x equals 3/4. So 3/4 is the value you have to plug in there to make those two ratios equal to each other. And the last one, here's an example of one. We didn't do this on the first one, but if you'd like to use the property that says it's, go ahead and swap the 2, you could. Swap the 2 if you wanted. You could put the x up here. It's equivalent to cross multiplying. If I cross multiply, I still get 9x equals 84. But yeah, you could swap this, put the x up there and the 9 down there, and then multiply by 14. That would be equivalent. It would look like this. You'd have, I'll just do it up here. X over 9 equals 6 over 14. Let's see, not x over 9. Sorry. Try that again. X over 14 equals 6 over 9. See how that works? I just swapped these two, the x and the 9. And then what would I do to each side to solve for x? not besides cross multiplying. If I have x divided by 14, what's the inverse operation of dividing by 14? Multiply by 14, right? So I just take 6/9 times 14, and that would give me the answer as well. It's the same thing as cross multiplying. So here, if I divide each side by 9, I'll just finish this off. I have x equals, it goes in 9 times with 3 left over. So what's my fraction? I'll tack on the end here. Yeah, third, 9 and a third. So there it is. So solving proportions, you're going to get to do some of that as well. All right. Down here we have just applying the properties. It says if P over 6 equals R over 10, then P over R equals 3 over 5. So I think I asked you which properties you use. So whether the statement, oh, just whether the statement is true or not. So the question is the statement true? You know, a really easy way to check this would be to cross multiply and look at the cross product. I have to do a little simplifying, but if you look at the cross product here, I have 10p equals 6r, and here I have 5p equals 3r. And if I divide this by 2 on each side, what do I end up with? 5p equals 3r. So is this equivalent? Yes, this is true. Do you see which property they're using for multiply? If they use one directly, but they swapped the 6 and the r. They swapped diagonally. I think it's property number 3. They swapped the 6 and the r, and then they reduced 6/10 to 3/5 is what they did. But it's true. Quick way to check it though is just to cross multiply here. What about here? This one's actually false. You see why? You see it? One issue here. It's okay. They put a plus 3 here. That's okay. They just added 1, but they're not actually adding 1 here. They're adding what to the c over 4? 3/4. What would this have to be right here to be true? Must be a 4 to be true. So this is false. And that's that final property that I put before. All right, example 6, similar type of thing here. We have a over 12 equals c over 3. What does a over c equal? So a over 12 equals c over 3, and what they're going to do, it looks like they're swapping a couple things here. So they're swapping the 12 and the c, it looks like. So the 12 would move up here, and that would be over the 3. That's all they're asking you to do. And if you want to, you can reduce the 12 over 3 to 4, or 4 over 1. But you can leave it 12 over 3. Then you see exactly what's happening. Once you reduce, it's kind of lose sight of what property they're using. So leave it just 12 over 3. And then here, 13 over q equals 10 over 2. So 13 plus q over q equals 10 plus what over 2? What needs to match here? Yes. We're really adding 1 to each side. So whatever you add to the top has to match the bottom so that it's equal to 1. So it's 10 plus 2 over 2 is what that should be. That's using property 4. So a little bit of practice with those properties that you're probably not real familiar with. The one that says you can swap diagonally anytime you want, and you can add something each side as long as whatever you add to one side, you add to the other. Okay? In other words, I'm adding q here, which is actually q over q or 1, and so over here I have to add 2, which is actually 2 over 2 or 1. All right. Right? New properties 3 and 4. Do you want to make a model boat in a bottle? There's an application problem. The length of the actual boat is 882.75 feet. 882.75 feet. So that's a big boat. So right, there's a football field. There's 300 feet. 100 yards, 300 feet. So that's almost 3 football fields. So and the width is 92.4 feet. It's a long, narrow boat. Your bottle is 22 inches long. how wide will the bottle have to be properly scale the boat? So just for fun. So I don't think this works, but anyways, properly you want to put it in there. Have a model here. So how wide will the bottle have to be to properly scale? So do you see 3 different values in here? Here's 1, here's 2, and here's 3. Well, let's see here. Let's box. Here's the actuals, right? Let's box the actuals. There's the actual. And then what I underlined here is the scale model. And don't look at this because this isn't. We're filling the whole bottle. We're just trying to be fun with the picture here. But we're going to fill the whole bottle, and it's going to go the whole width of the bottle too for this to work. Okay, so it's just fitting in there, just snug. The 22 inches long is the scale model portion that goes with the 882.75. So when you set up a proportion here, here's how it works. And there's different ways to set it up, but if I want to take the 2 values I boxed, those are the actual values, 882.75 feet over 92.4 feet. That's length over width, and this is the actual. Now we're going to set that equal to the model. But when we set it equal to the model, we need to make sure that straight across here and straight across here, we have same dimensions. So the 22 inches long, different units, but it's representing the length of the ship, right? So the 22 either has to go on the top or the bottom. It's going to go on the top because it needs to correspond to the length and feet of the actual ship. Does that make sense? If you remember talking about this in algebra, but it's like you've got to have length to length and width to width. And if I switched them up and put width on top, it would go width to width on the top and length on the bottom. Okay. There are other ways you could set it up. You could have length of the actual over length of the model. That would be fine. You just have to have width of the actual over width of the model here. So there's different ways to set it up. You just need to make sure that corresponding parts are in the right places. So on the bottom here, I would have X. That's what it would look like. So one more time. The reason I have X on the bottom is because that corresponds to width of the actual boat. That's what I'm trying to find. Okay. Is that clear? So cross multiply to solve. Why don't you go ahead and cross multiply this? This one you can cross multiply the 92.4 and the 22 and then divide by the 882.75. That 92.4 is significantly less than the 882.75, so the width of this bottle is not very wide. What do you end up with? Yeah, 2.3 inches. 2.30. Okay. We're gonna go ahead. Let's put little squiggly equals at 2.3 inches. Yeah. I'm not gonna try and find a fraction for what you just said. Yeah. Yeah, right. So about 2.3 inches. Yeah. Which makes sense because this is about a tenth of that, and that's about a tenth of that. Makes sense. That's the cool thing about proportions. Like, they'll make sense if you've done it correctly and think about it. But any questions on that?